For this problem, we're asked to start with 4.2 milliliters per hour and calculate the micrograms per kilogram per minute. Again, we're going to do this problem using dimensional analysis because there are so many conversions involved. Like before, we start by putting the conversion into a vertical fraction form. So 4.2 milliliters over 1 hour. Now, our conversion is exactly backwards of what we've previously done. Before we started with the micrograms per kilogram per minute and worked to milliliters per hour. Now we're going the opposite direction. We still want to start by converting our time. So this time 1 hour goes in the numerator so that it cancels with the hour that's in the denominator, and we know that 1 hour is the same as 60 minutes. So that gives us the first label that we're looking for. We're looking for minutes, and we have minutes. Next, I'm going to work to get micrograms. So in the problem I'm given milliliters. If I use the dosage strength, we have 500 milligrams in 250 milliliters. This will allow me to convert. The 250 milliliters goes in the denominator so that it will cancel, and it goes with the 500 milligrams. I'm closer to my desired label, but I've now got to change milligrams into micrograms. So we've talked about before that 1 milligram is 1,000 micrograms. And we can remember 3 zeros because with the King Henry method, we would move our decimal 3 places. So now milligrams is canceled, and I have micrograms, the second piece of the label that I want. The remaining piece of the label that I want is a per kilogram. I want kilograms to be in the denominator. So I'm going to multiply this by 1 over 70.5 kilograms. Now, that may feel awkward to you because there's no label to cancel. And that's important because we went from 2 labels in our original to 3 labels in our answer. So we have to introduce this additional label. The kilograms is in the denominator, so it's very important that we put the kilograms in the denominator. Typically, when we did the first conversion, we don't have a problem with putting a number over 1 because we know that the value is still the same. However, the value of 1 over 70.5 is not the same as just 70.5. The value is definitely changed. That's okay here because it's a conversion. The one patient, and I know we don't use the label of the patient, but we know that this is making the dose specific to our client. The one patient has this weight, and so this is a conversion factor and truly can be used either with the one on the numerator or the one on the denominator. Now it's time for us to do the math. So we take 4.2 times 1 times 50 times 1,000. We can multiply by 1, but we really don't have to. Then we start dividing, so we divide that answer by 60, divide by 250, and divide by 70.5. And when I do that on my calculator, I get 1.985, and the decimal continues. So we're going to round to tenths just like we did with the milliliters per hour. So the 9 is in the tenth spot. When I look, I have an 8 in the hundredths, so the 9 rounds up. So this rounds to 2.0. We never write an extra 0 in metric, so we're going to write our answer as 2 micrograms per kilogram per minute. And that's very reassuring because we had gotten 4.2 as our initial milliliter per hour rate, and the minimum dosage, or the initial dosage from the problem, was 2. So we did truly work back to start.